So today we're going to examine a food pyramid on a faraway planet. And according to the story, you have vortexes, which are kind of like the producers, like they'd be like plants on Earth. And they are eaten by snives. And then the snives, a primary consumer, is eaten by klukes, which are secondary consumers. Now, one thing you notice right away is there's a error on the handout, because the arrows are pointing the wrong way. So remember, the arrows are supposed to go in the direction of the energy flow. The way they're showing it, they're trying to show who eats whom, which is wrong. So the first thing you need to do is scratch out the existing arrows and place arrows in the opposite direction. The first activity, part one of the activity, is basically drawing a food pyramid. And so it says that the height is always the same for each of the rectangles representing each of these individuals, populations, species. So each of these species is represented by a rectangle which is 5 centimeters tall. And then the width of it depends on how many individuals you have. And it shows right here that you have 100 vortexes, you got 50 snives, and you've got 25 klukes. So 100, 50, and 25. So how would you draw that? So what you need to do is you need to center 3 rectangles using a paper ruler or an actual ruler, and measure for each rectangle. You're going to have a 5 centimeter height, so they're always 5 centimeters, and then the width is 1 centimeter per 10 individuals. So the bottom one was 100 individuals, so you're going to have 10 centimeters, and the second one was 50 individuals, so you're going to have 5 centimeters, basically dividing the population by 10. And the top one was 25 individuals, you have 2.5 centimeters. So again, you had 100 vortexes. So we said 1 centimeter per 10. So this would be 10 centimeters, 50 snives. Again, 1 centimeter per 10 would give you 5 centimeters in width. And again, klukes, 25, same thing, 1 centimeter per 10 of them, so 2.5 centimeters. And then the next step is to join them. So it says to draw a line which joins all of the boxes, just like that, on both sides. And then it asks you some questions about it, like why is it that shape? You gotta think about that. So you're done with this part. That's what we just did. The next thing is to answer questions about the drawing you just made. It's going to answer those questions right there. Okay, the next part on the back of the paper, I have to provide you with it says your teacher will provide you with information about an actual ecosystem. And so the information is right there. There are 3 ecosystems. And so you're going to follow the instructions looking at each of these 3 ecosystems. So for each of the 3 ecosystems I just showed you, you're going to answer number 1, or do number 1, and number 2. So right there, number 1 and 2, based on the 3 ecosystems I just showed you. And then for each of the 3 ecosystems, which are the forest, the Chesapeake Bay estuary, and the island in the Galapagos, you're going to draw a table that shows the effect of each member of the food chain on the rest of the food chain, just like that. So I will help you with the first one, the forest. With the forest, you have 75 plants as organism 1. You have 20 rabbits, that's organism 2, and you have 4 foxes as organism 3. So I've put the plants, rabbits, and foxes as organisms 1, 2, and 3 on both axes. So plants, rabbits, foxes on the y-axis, plants, rabbits, foxes on the x-axis. So in the first line I put an X because organism 1 is removed. What happens to the rest of the food chain? Well, if 1 is removed, what does 2 eat? Nothing. What can 3 eat if 2 can't eat? Nothing. Because if 1 is removed, which are the producers, everybody else dies. What would organism 2 eat? There's nothing to eat. 3, there's nothing to eat. So they're going to go down and eventually become extinct. So I have put an arrow to show that they go down, and then the next they become extinct. An arrow, they go down, and next they become extinct. Okay, next I'm going to put an X on line 2, and so the rabbits are gone. So if the rabbits are gone, what happens to the plants? Well, they do really well, correct? Because there's no rabbits to eat them. So I put an arrow for the plants showing that they go up. So the rabbits are gone, plants do well. Okay, the third line, if the rabbits are gone, what happens to the foxes? So the foxes have nothing to eat, so they go down, and then eventually, what do you think happens? They keep going down, they have nothing to eat, they die. So I put an X to show that they go down, and then eventually they die. And you can figure out how to do the next one. What's going to be taken out? The foxes. So if the foxes are removed, what happens to the rabbits? Now that's a tricky question, because initially the rabbits do well. So I put an up arrow to show that the rabbits do well. And then what happens to the plants when the rabbits do well? They don't do so well because the rabbits eat them. So I put a down arrow to show the plants don't do so well, but it's not all over yet. Because if the plants don't do well, what happens to the rabbits now? They're going to go down because they're running out of food. And so when the rabbits go down, what happens to the plants now? Well, they start to recover and they go up again. And this up and down cycle continues for a while. So up and down,